This is part 2 of how to use artificial intelligence to make a simulation model of just about anything. In part 1, I showed you how to make a Python script which trained an artificial neural network model on some random data. In part 2, we're going to find some more realistic data and extract a model from that, and then we'll bring this model into the ADS simulation environment. If you missed part 1, you can find it on our YouTube channel, Keysight ESOP. Okay, let's go find some data. All we need is a picture of a graph of some electrical characteristic. Now, since I've got a background in power amplifier design, I found this Keysight application note for one of our ENA network analyzers. You can download this document at the link shown here. This is a pretty good read on RF amplifier measurements. Anyway, on page 18, I found this picture of an amplifier measurement showing the gain and phase response with a swept input power. So input power is on the x-axis here. This is just an image, so obviously we need to get points from these graphs in order to train an ANN model. There are several interesting Python libraries out there that do just this sort of thing. Some of them even use AI to get the points off of a picture graph. I'll let you explore that on your own, but for this exercise, I extracted the x and y points the old-fashioned way. I just estimated them by hand. I put them into an Excel spreadsheet and made some plots to verify that they looked close to the original data. Now, you might remember from the last video that the ANN training takes text input files which are space delimited. Now, I'm in Excel here, which isn't the right format. So to get this into the right format, all I need to do is copy this data, and then over in VS Code, I'll create a new text file, and I just paste the data in directly from Excel. So let's save this file as amplifier.txt. Okay, in the training script, we need to change a couple things. First, we need to change the name of the input file to that amplifier.txt that we just made. And it's also necessary to change the ANN setup. In this case, there are two outputs, gain and AM to PM. So I need to change those, and then we can run the script and train the model. Again, this training produces two files just like before, an output file and a simulation file. So let's turn our attention to this output file. That file contains two equations because there are two outputs in this case. And these equations are really long, but if you look closely, you can see these underscore V1 terms in both of the equations. That's actually the input, which in this case is power. And then these Y values all the way on the left, those are the outputs. Those are going to be gain and AM to PM respectively. So the first thing I like to do is make this more explicit. So I'm going to find all of those underscore V1 terms and replace them with the term PN. And then I'll replace the Y1 term with gain, and the Y2 term, I'll replace that with AM to PM. Now these equations are hopefully a little more understandable. The next step is to get these equations into the simulation environment somehow. So switching over to ADS, I've got version 2024 running, and I have a DC simulation set up here already. It's very basic. So how would you bring these equations in? Well, to do that, I can just add a variable block to the schematic, and then I'll double click on it, and I'll change this entry mode to name equals value. Then let's pop back to VS Code to that text file, and I'm just going to copy the first equation out of that text file, and I'll go back over to ADS and literally paste it into the equation block. That's Control-C and Control-V, and then I'll hit apply, and there it is. And now I'll repeat the process for the second equation. Again, copy that from VS Code, come back over here to ADS, and in this case, I want to be careful to press the add button so that there's actually two equations. Okay, so the only thing left to do is add a variable for PN. Remember, this is the input to the ANN equation, so let me do that. And then I'll configure the DC controller to sweep this PN variable from -15 to +5. That's the range of the training data. Also, I want to output these variables to the data set, so go to the Output tab and click Add Remove to add them in. All right, so now we'll run the simulation, and it's very quick. You can see there's the data display. And I'll just add a rectangular plot, and we can add the gain output here, and then we can add another one for AM to PM. And if you look at these plots and compare them, they're pretty close representations of the original training data from the app note. Now, going back to the schematic, what happens if the sweep's outside the training range? So like if we tried from -20 to +10 and reran the simulation, you can see that the output, the curves are still smooth, and that's definitely an advantage of ANN modeling. But who knows if this is valid data or not. So it might be a good idea to apply a limit to the input. And I'll show you how to do that now. Let's go back to the schematic. And I'll just add a new variable here, x. And in the DC controller, instead of sweeping p in, I'm going to sweep x. So now I'll modify that p in variable. And I'll say if x is less than minus 15, then minus 15. Else, if x is greater than 5, then 5. Else x and if. In other words, if x is below the training range, set it to the minimum. If it's above the training range, set it to the maximum. Okay, let's rerun the simulation to show the limits, and there you have it. This is a well-behaved ANN model inside of ADS. You might be thinking, well, these are only variables. It's not quite a circuit model. In the next video, part 3, I'll show you how to take these variables and build a real electrical model that you can use in a circuit. And you can find that on our YouTube channel. Please like and subscribe if you find these tutorials useful.